November 24, 1944. 31,000 feet above the outskirts of Tokyo, Japan. First Lieutenant James Thompson gripped the control yoke of his B-29 Superfortress, designated 42-6273, as black puffs of anti-aircraft fire erupted 4,000 feet below his aircraft. The altimeter needle held steady. The oxygen flow indicator pulsed rhythmically in the instrument panel's dim red glow. Through the Plexiglas windscreen, 87 other silver giants maintained formation, their contrails drawing chalk lines across the winter sky. Thompson's bomber flew at an altitude where the air outside registered 40 degrees below zero. Yet inside the pressurized forward compartment, he and his copilot breathed normally, their hands steady on the controls despite the thin atmosphere that surrounded them. 4,000 feet beneath their formation, Japanese Type 88 75mm anti-aircraft guns hurled shells upward, straining against the physical limitations of their maximum effective ceiling. The explosions detonated in frustrated clusters, their shrapnel dissipating harmlessly in the stratosphere below the American bombers. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. This disparity represented more than a tactical advantage. It embodied an acknowledgement that Japanese military planners had spent the previous 5 months desperately trying to avoid. American bombers now operated in a realm where Japanese defenses could not reach them. The altitude itself had become a weapon more decisive than any bomb or bullet. The mission designation was San Antonio 1, the first strategic strike against Tokyo from the recently captured Mariana Islands, 1,500 miles to the south. Unlike the long, fuel-constrained missions from distant Chinese bases that had characterized earlier B-29 operations, these bombers could now strike Japan's heartland regularly and return safely. The technological foundation for this capability rested in the pressurization systems that allowed crews to function effectively at heights where Japanese interceptors gasped for oxygen and struggled to maintain controlled flight. Thompson's aircraft carried 10 crewmen, 6 tons of high-explosive bombs, and a defensive armament of 12 50-caliber machine guns controlled by an analog computer fire control system. But the bomber's most potent defensive asset was invisible, unmeasurable in specifications or tonnage. It was altitude, 31,000 feet of vertical separation between American aircraft and Japanese guns, 31,000 feet of air so thin that conventional fighters lost power, maneuverability, and the ability to sustain combat. Behind Thompson, in the bomb bay and aft pressurized compartment, his crew prepared for the target approach. Bombardier Captain William Harrison adjusted the Norden bomb sight, compensating for ground speed and wind drift. Navigator Second Lieutenant Robert Chen verified their position against dead reckoning calculations and celestial fixes taken during the 6-hour flight from Saipan. In the Central Fire Control Station, Sergeant Michael O'Brien monitored the defensive armament, ready to direct coordinated fire from multiple turrets against any Japanese fighters that managed to climb into engagement range. The date marked a threshold in the Pacific War's air campaign. 5 months earlier, on June 15, 1944, the first B-29 strategic bombing mission against Japan had launched from Chengdu, China. 75 superfortresses attempted that mission against the steelworks at Yawata on Kyushu, with only 47 reaching the primary target. The raid demonstrated both the B-29's potential and the severe challenges ahead. 7 aircraft were lost, including 1 shot down over target by a Kawasaki Ki-45 twin-engine fighter. 57 airmen died, yet even this costly introduction revealed a crucial fact. Japanese defenses struggled against high-altitude bombers. The Yawata mission had forced B-29 seconds to operate at altitudes between 8,000 and 21,000 feet, constrained by fuel requirements for the extended mission from China. Even at these relatively modest heights, Japanese interceptors experienced difficulty. Their Nakajima Ha-25 engines, rated at 1,080 horsepower each, lacked effective supercharging for high-altitude operations. Above 20,000 feet, these engines produced perhaps 60% of rated power, leaving fighters barely capable of maintaining level flight, much less executing combat maneuvers. But today's mission from the Marianas demonstrated a different calculus entirely. With 1,500 miles separating Tokyo from Saipan, instead of the vast distances from Chinese bases, Thompson's bomber group could operate at their designed combat altitude, 30,000 feet and above, the realm where pressurization technology separated survival from hypoxia, where American engineering created an operational advantage Japanese industry could not match. The conceptual foundation for this capability had been established years earlier, during the bomber's development phase. In February 1940, General Henry H. Arnold, Chief of the Army Air Forces, authorized specifications for an advanced strategic bomber capable of extended-range missions in the Pacific Theater. Arnold recognized that defeating Japan would require bombers capable of reaching targets from distant bases across vast oceanic expanses. The resulting aircraft incorporated technologies that represented fundamental departures from existing aviation practice. Pressurization emerged as the B-29's most revolutionary feature. Engineers at Boeing's Wichita, Kansas facilities designed sealed compartments that maintained an internal environment, equivalent to 8,000 feet altitude, while the aircraft flew at external altitudes, approaching 30,000 feet. This capability meant crews could operate effectively for 10 to 12-hour missions without the debilitating effects of hypoxia, cold, and fatigue that plagued crews in unpressurized bombers. The system employed engine-driven compressors that forced outside air through heat exchangers before delivering it to 3 separate pressurized compartments. The forward crew station, containing pilots, bombardier, navigator, and flight engineer, a connecting tunnel running above the unpressurized bomb bays, and the aft compartment housing gunners and the tail gunner position. Differential pressure regulators maintained approximately 8 pounds per square inch pressure difference between interior and exterior environments at maximum altitude. Japanese military intelligence had tracked B-29 development through various sources, including technical publications, diplomatic contacts before the war's outbreak, and analysis of crashed aircraft recovered during Operation Matterhorn missions from China. Yet, understanding the technology and possessing the industrial capacity to implement equivalent systems represented fundamentally different challenges. Japan's aviation industry, stretched desperately thin by war demands, could not replicate the precision manufacturing, quality control, and production scaling that characterized American bomber production. By November 1944, Boeing, Bell, and Martin factories were producing over 200 B-29 seconds monthly, each incorporating pressurization systems manufactured to exacting specifications. General Electric and Garrett I Research supplied the compressor systems. Hundreds of subcontractors provided seals, valves, regulators, and control mechanisms. The entire industrial effort represented capabilities that Japan's war-damaged economy could not approach. Thompson's formation approached the initial point for their bomb run. Below and to the west, Tokyo's urban sprawl stretched across the Kanto Plain, partially obscured by industrial haze and scattered clouds. Japanese radar operators had detected the incoming formation an hour earlier, allowing air defense units time to scramble interceptors and prepare anti-aircraft batteries. But the defenders faced a problem without solution. Their guns could not reach 31,000 feet, their fighters could barely climb to interception altitude, and those that succeeded arrived with severely degraded performance, burning excessive fuel, and operating engines dangerously close to overheating. The fundamental equation of high-altitude interception had turned catastrophically against Japanese defenders. A fighter climbing from ground level to 30,000 feet consumed perhaps 30 minutes, and burned approximately 1/3 of its fuel load. At altitude, fighter performance degraded dramatically. Guns remained deadly at close range, but closing to firing distance required pilots to approach within a few hundred feet of targets, a maneuver made nearly impossible by reduced aircraft performance and the B-29's sophisticated defensive fire control systems. Coordinating multiple turrets. Even successful interceptions often proved Pyrrhic victories. Damaged or fuel-depleted fighters attempting to return from extreme altitude frequently crashed, killing experienced pilots that Japan could not replace. The mathematics of attrition favored the bomber force absolutely. Major Makoto Ogawa, who would eventually claim 7 B-29 kills to become one of Japan's most successful Superfortress hunters, later described the overwhelming disadvantage Japanese pilots faced. American bombers flew in a realm where Japanese aircraft barely functioned. Americans enjoyed pressurized cabins with heated compartments. Japanese pilots endured temperatures 40 degrees below zero at high altitude, their fingers numb despite electrically heated. Flight suits that rarely worked properly. Oxygen systems frequently malfunctioned, leaving pilots hypoxic and disoriented. Gun barrels froze. Ammunition belts jammed in extreme cold. Engines ran so rough that pilots constantly feared complete failure. Thompson's bombardier called adjustments over the intercom. The formation's lead aircraft, carrying the mission's primary bombardier, would control the bomb release. The other aircraft would toggle their loads on the leader's signal, a tactic designed to concentrate explosive effect on the target area. The technique worked well for area bombing but provided limited precision against specific industrial facilities, particularly when high-altitude winds and the recently discovered jet stream affected bomb trajectories unpredictably. The target today was the Musashino Aircraft Engine Plant, part of the Nakajima Company's manufacturing complex on Tokyo's outskirts. Intelligence estimated this facility produced approximately 30% of Japan's aircraft engines, making it a priority target for strategic disruption. The plant occupied approximately 120 acres, with multiple assembly buildings, machine shops, and testing facilities. Destroying this production capacity would directly impact Japan's ability to replace combat losses and maintain fighter strength. But weather conditions complicated the attack. Dense clouds obscured portions of the target area. Jet stream winds, still imperfectly understood by American meteorologists in late 1944, reached velocities exceeding 200 miles per hour at bombing altitude over Japan. These winds, discovered accidentally during earlier high-altitude missions, could push bombs miles off target if bombardiers failed to compensate correctly during their approach. The formation's progress attracted increasingly desperate attention from Japanese defenders. Ground controllers vectored interceptors toward the bomber stream, coordinating what fighters could reach altitude for engagement attempts. Captain Teruhiko Kobayashi of the Imperial Army's 244th Sentai, one of Japan's most skilled fighter leaders, led his unit aloft in Nakajima Ki-84 Hayate fighters. These represented Japan's finest mass-produced fighters, incorporating lessons learned from earlier designs and featuring the Nakajima Homare engine, rated at approximately 1,800 horsepower. On paper, the Ki-84 appeared formidable. Maximum speed around 400 miles per hour at 20,000 feet, service ceiling approaching 35,000 feet, heavy armament of 30mm and 20mm cannon. In practice, few operational Ki-84 seconds achieved these specifications. Poor quality fuel-damaged engines, crude lubricants broke down at low temperatures encountered at altitude. Manufacturing defects, inevitable products of Japan's deteriorating industrial quality control, caused frequent mechanical failures. American pilots who test flew captured Ki-84 seconds. After the war, praised the aircraft's handling and performance, noting it matched or exceeded American fighters in certain respects. But they observed that these captured examples had been selected for exceptional condition, maintained by skilled mechanics using hoarded high-quality materials. The average operational Ki-84 performed far below design specifications, a gap that widened as Japan's industrial situation deteriorated throughout 1945. Kobayashi's fighters climbed aggressively, pushing engines to maximum power in desperate attempts to reach the bomber formation's altitude before it completed its attack run. Several interceptors managed to close within visual range of the B-29 formation, positioning for firing passes. But at 31,000 feet, the Japanese fighters moved sluggishly, their pilots struggling with controls that felt mushy and unresponsive in the thin air. Closing speeds made accurate gunnery nearly impossible. The few pilots who managed firing opportunities found their attacks disrupted by coordinated defensive fire from multiple B-29 turrets. Thompson's aircraft shuddered slightly as nearby bombers released their loads. The intercom crackled with the bombardier's call. Bombs away. 6 tons of high-explosive ordnance tumbled free, beginning their 3-mile descent toward the target below. The bomber lurched upward slightly, relieved of its deadly cargo's weight, Thompson maintained formation position, holding steady course and altitude, while the bombardier documented the strike with gun camera footage. Below the formation, anti-aircraft shells continued their futile barrage. Of the approximately 240 rounds fired at Thompson's group during the bomb run, not one exploded close enough to inflict damage. The guns simply could not reach targets at 31,000 feet with sufficient accuracy or consistency to pose meaningful threat. Japanese anti-aircraft crews, aware of their weapons' limitations, nonetheless fired continuously, demonstrating resolve in the face of technical inadequacy. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The formation turned south, beginning its withdrawal toward the Boso Peninsula and the open Pacific beyond. Thompson checked fuel gauges and engine instruments, calculating the 6-hour return flight to Saipan. Behind him, Tokyo's anti-aircraft batteries continued firing, their shells bursting uselessly thousands of feet below the departing bombers. The mission had achieved mixed results. Only 24 of the 88 aircraft over Tokyo successfully bombed the primary target. Dense cloud cover and navigational challenges in the jet stream winds had scattered the remaining bombs across secondary objectives. But the psychological impact on Japan proved profound. American bombers had struck the capital with virtual impunity, and Japanese defenses had failed to prevent it. 3 months later, on February 19, 1945, a different B-29 crew experienced the full measure of Japanese desperation and the extraordinary survivability that high-altitude operations provided. Captain Paul Henderson piloted B-29 serial number 44-69873, nicknamed Pacific Pioneer, on a daylight raid against the Nakajima aircraft plant in Ota, northwest of Tokyo. His aircraft flew at 30,000 feet as part of a 150-plane formation targeting Japan's dispersed aircraft manufacturing facilities. Japanese defenders, recognizing that conventional interception tactics achieved minimal results against high-altitude formations, had begun implementing more aggressive and suicidal measures. Specialist ramming units formed within several fighter sentai, their pilots trained to deliberately collide with B-29 seconds after exhausting ammunition or when conventional attacks proved ineffective. These tactics represented ultimate acknowledgement of defensive inadequacy. When guns and tactics failed, only deliberate self-sacrifice offered any prospect of downing the silver bombers. Henderson's aircraft attracted attention from a flight of Kawasaki Ki-61 Hien fighters scrambled from Chofu Airfield. These liquid-cooled inline-engine fighters could reach altitudes around 32,000 feet, higher than most Japanese interceptors, though climb rate remained insufficient and engine reliability so poor that many Ki-61 seconds were perpetually grounded, awaiting spare parts that never arrived. 3 fighters closed on Pacific Pioneer's left flank, firing their 20mm cannons in careful bursts to conserve ammunition while closing range. The first shells struck the bomber's wing, punching holes through aluminum skin but missing critical structural members and fuel tanks. Henderson's left waist gunner, Staff Sergeant Thomas Riley, returned fire from his remote-controlled turret station, the analog computer automatically calculating lead and deflection angles as he tracked the attacking fighters through his optical sight. Tracer rounds stitched through the thin air, forcing one Ki-61 to break away with smoke, trailing from its engine cowling. But the remaining 2 fighters pressed their attack with desperate determination. More cannon shells struck Pacific Pioneer's fuselage and wings. A 20mm round penetrated the forward pressurized compartment, creating a 3-inch hole that immediately began depressurizing the cabin. Emergency oxygen systems activated automatically as internal pressure dropped. Henderson and his co-pilot donned oxygen masks, while the flight engineer worked frantically to seal the breach with emergency repair materials carried for exactly such contingencies. The navigator, First Lieutenant David Morrison, counted holes appearing in the aircraft's structure as cannon fire continued raking the bomber. 7, 12, 18. The attacks seemed to continue endlessly, though actual engagement time lasted perhaps 90 seconds. Morrison documented what he could observe from his station. multiple strikes to wings, fuselage, vertical stabilizer. Lost. Pressurization. Number 3. Engine showing decreased oil pressure. Rudder controls sluggish but functional. 1 Key 61, piloted by Warrant Officer Isamu Nakamura, exhausted his ammunition without achieving what he considered decisive hits. In the desperate calculus that governed Japanese interception tactics by early 1945, Nakamura made his final decision. He turned his fighter directly toward Pacific Pioneer's tail section, accelerating to maximum speed for a ramming attack. The impact would certainly destroy his aircraft and kill him, but it might also cripple the B-29 sufficiently to send it down. Henderson saw the fighter approaching through his rearview mirror, its propeller disc growing larger as closing speed exceeded 500 miles per hour. The tail gunner, Sergeant James Chen, fired continuously, his twin 50-caliber machine guns hammering streams of armor-piercing rounds toward the incoming fighter. At the last moment, either Chen's fire or Nakamura's own survival instinct caused the Japanese pilot to veer slightly. Instead of striking the tail assembly squarely, the Key 61 clipped the B-29's left horizontal stabilizer, shearing off 3 feet of aluminum structure before tumbling away in an uncontrolled spin. Nakamura did not survive. The collision sent violent shudders through Pacific Pioneer's airframe. Henderson fought the controls as the aircraft yawed left, its damaged stabilizer creating asymmetric aerodynamic forces. The rudder pedals felt mushy, hydraulic pressure falling as damaged lines leaked fluid, but the bomber remained controllable. The primary wing spars, though perforated by cannon fire, retained structural integrity. The 4 Wright R-3350 engines continued running, though number 3 showed fluctuating oil pressure indicating probable damage to its cooling system. Morrison completed his damage assessment as the formation withdrew from the target area. His count reached 52 separate holes in the aircraft's structure, 52 punctures from 20mm cannon shells, plus the collision damage to the horizontal stabilizer, plus the depressurization breach in the forward compartment. Any conventional aircraft would have been destroyed. Most World War II bombers receiving such damage fell from formation and crashed or were forced to emergency landing attempts. But Pacific Pioneer, designed for high-altitude operations with redundant systems and robust construction, continued flying. The 6-hour return flight tested both crew and aircraft. Henderson gradually descended to lower altitudes, where the crew could remove oxygen masks after sealing the pressurization breach as well as possible. Number 3 engine eventually overheated and had to be shut down, its propeller feathered to reduce drag. Pacific Pioneer flew on 3 engines, maintaining formation position with difficulty, but never falling so far behind that it became isolated and vulnerable to follow-up attacks. The bomber reached Saipan with fuel reserves nearly exhausted. Henderson brought the damaged aircraft in for landing, the touchdown smooth despite degraded control response. As ground crews swarmed over Pacific Pioneer, examining the extensive battle damage, they counted and catalogued every hole and structural deformation. 52 cannon shell penetrations, 3 feet of horizontal stabilizer missing, 1 engine destroyed, hydraulic system partially compromised, pressurization system breached. Yet the aircraft had flown 6 hours and 1,500 miles back to base, carrying its full crew without casualties. This incident, repeated in variations across dozens of missions, fundamentally shaped Japanese strategic assessments of the B-29 campaign. The bomber's ability to absorb tremendous damage and continue functioning demonstrated not just engineering quality, but systematic industrial advantages that Japan could not overcome. When Lieutenant Fumio Niwa, an engineering officer, examined captured B-29 components later in the war, he documented findings that survived in Japanese military archives. The aircraft's construction incorporated redundant systems, armored protection for critical components, and manufacturing quality that exceeded anything Japanese industry produced. Examining wreckage from crashed B-29 seconds in China and later in Japan itself, Niwa's analysis noted specific details that revealed the industrial chasm between American and Japanese capabilities. Structural members were machined to tolerances measured in thousandths of an inch, Aluminum alloys used throughout the airframe possessed consistent material properties, indicating rigorous quality control in smelting and fabrication. Even mundane components like hydraulic fittings and electrical connectors demonstrated precision manufacturing that Japanese factories, operating with inadequate machine tools and increasingly unskilled labor, could not replicate. More devastating was the systematic nature of American production. Boeing's Wichita plant alone manufactured hundreds of B-29 seconds monthly, each meeting exacting specifications verified through automated testing procedures. Defective components were identified and rejected before reaching operational aircraft. Japanese intelligence compiled reports estimating that by mid-1945, over 1,000 B-29 seconds operated from Mariana bases, representing an industrial capacity that completely overwhelmed any defensive countermeasures Japan could implement. By March 1945, Japanese military leadership confronted bitter reality through multiple channels of evidence. Colonel Takushiro Hattori, operations officer at Imperial General Headquarters, documented in personal diary entries that American bombers operated with effective impunity at altitudes Japanese fighters could not reliably reach. When interceptors managed engagement, the B-29's rugged construction absorbed damage that would destroy Japanese aircraft. Most alarming was the recognition that the bombing campaign represented only the beginning. American production capabilities suggested thousands more B-29 seconds would eventually attack Japan, each one beyond effective defensive reach. Lieutenant General Noboru Tazoi, commanding Japan's air defense forces, reached a definitive conclusion after analyzing combat reports from the devastating fire raids of March 9 through 19, 1945. During this 5-mission blitz against Tokyo, Nagoya, Osaka, and Kobe, Japanese defenses achieved a loss rate of approximately 3% against the attacking formations, higher than earlier high-altitude raids, because these attacks occurred at lower altitudes between 5,000 and 9,000 feet. But even this marginally improved defensive effectiveness came at catastrophic cost to defending forces and proved insufficient to prevent the destruction of 32 square miles of urban industrial area. Tazoi's post-war statements, documented during interrogations conducted by the United States Strategic Bombing Survey, acknowledged what Japanese commanders understood by spring 1945. The altitude advantage enjoyed by B-29 seconds during daylight, precision raids made effective defense essentially impossible with available Japanese technology and resources. When bombers operated at 30,000 feet, few aircraft and anti-aircraft guns could effectively engage them. The jet stream winds that complicated bombing accuracy simultaneously protected the bombers by dispersing anti-aircraft fire and forcing interceptors to burn excessive fuel climbing to altitude through headwinds. Japanese aircraft designers desperately sought solutions throughout late 1944 and early 1945. The Nakajima Ki-87, developed specifically as a high-altitude B-29 interceptor, incorporated a turbo-supercharged Nakajima Ha-219 engine, intended to deliver effective performance above 30,000 feet. On paper, the design appeared impressive. Service ceiling, above 40,000 feet, heavy armament of 30mm and 20mm cannon, speed sufficient to overtake B-29 formations. Only one prototype flew before war's end in April 1945. The aircraft demonstrated severe problems. The turbo-supercharger, assembled from inadequate materials with insufficient testing and development time, failed repeatedly. Even when functioning, it delivered inconsistent performance. The project died not from lack of engineering skill but from absence of industrial capacity to produce reliable, complex components at scale. Japanese engineers understood what was needed. They possessed theoretical knowledge and design capability, but they lacked the machine tools, quality control systems, precision manufacturing infrastructure, and uninterrupted production facilities necessary to transform designs into operational hardware. The Tachikawa Ki-94, another proposed high-altitude interceptor, never progressed beyond mock-up stage. The Mitsubishi J-8M rocket-powered interceptor, based on the German Me-163 Comet, offered high-altitude capability without turbo superchargers. but dangerous rocket fuel and extremely short endurance, approximately 5 minutes, powered flight time, made it impractical for defending against B-29 raids that could approach from multiple vectors across extended timeframes. American B-29 operations expanded relentlessly through spring and summer 1945. By May, the monthly sortie rate exceeded 1,200 missions. Japanese fighter production, already declining from strategic bombing damage to manufacturing facilities, fell catastrophically as raw material shortages, transportation disruption, and labor force depletion combined with direct bombing effects. Monthly fighter output dropped from 2,100 units in mid-1944 to fewer than 1,200 by January 1945, continuing to decline through war's end. Pilot training programs collapsed entirely. Fuel shortages meant student pilots received perhaps 50 hours flight training compared to 200 to 300 hours American pilots received. These inadequately trained pilots flew obsolescent or poorly maintained aircraft against opponents who enjoyed every advantage. Numerical superiority, technological edge, operational experience, and most critically, the altitude sanctuary that pressurization technology provided. The final missions, flown before Japan's surrender in August 1945, demonstrated the complete breakdown of defensive capabilities. On August 14, 1945, the day before surrender announcement, over 300 B-29 seconds attacked targets near Tokyo, encountering virtually no opposition. Japanese fighters remained grounded, conserving fuel for the expected American invasion that would never come. The strategic bombing campaign had achieved its objective not through any single mission's destruction, but through cumulative degradation of Japan's industrial capacity, transportation networks, and ability to sustain military operations. The human cost of this technological disparity extended beyond military casualties. The B-29 campaign delivered 147,000 tons of bombs on Japanese targets, destroyed 40% of urban industrial areas in 66 cities, and killed an estimated 330,000 civilians. The fire raids alone displaced 8.5 million civilians from their homes. Industrial production declined 80% by July 1945. Transportation networks ceased functioning. Workers abandoned factories to flee burning cities or search for food in countryside increasingly cut off from urban centers. American losses, while significant, remained operationally sustainable. Of 414 B-29 seconds lost to all causes during the Pacific War, 147 fell to enemy action, Flak, and fighters combined. The remaining 267 losses resulted from mechanical failures, takeoff crashes, and the persistent engine fire problems that plagued the Wright R-3350 throughout its operational life. The loss rate of approximately 1.4% of sorties flown represented harsh arithmetic, but sustainable within the logic of strategic warfare. 3,015 aircrew died, were wounded, or went missing. Each loss carried individual tragedy, but the campaign achieved its strategic objective. Post-war American analysis, compiled in the comprehensive United States Strategic Bombing Survey, concluded that the B-29 campaign was decisively effective in destroying Japan's capacity to wage war. Survey authors debated whether Japan would have surrendered without atomic bombs or the planned invasion, but unanimously agreed that by August 1945, American air supremacy was complete and Japanese defenses were shattered. The B-29's technological advantages, particularly high-altitude capability enabled by pressurization systems, made this outcome inevitable once sufficient bombers became available and Mariana air bases became operational. Japanese records captured after the war revealed the extent to which B-29 raids dominated military planning from late 1944 onward. Imperial General Headquarters devoted enormous resources to air defense, pulling fighter units from other theaters, constructing thousands of anti-aircraft positions, training tens of thousands of troops for airfield defense. All efforts proved futile against bombers operating beyond effective defensive reach. The lessons Japanese engineers learned from examining American aviation technology influenced post-war Japanese industrial development. Emphasis on precision manufacturing, quality control, and systematic engineering that characterized American bomber production became hallmarks of Japan's post-war economic transformation. Former aviation engineers moved into civilian industries, bringing hard-won understanding of advanced manufacturing techniques. The pressurization technology that had enabled B-29 seconds to dominate Japanese skies represented everything Japan's wartime industry lacked but would master in subsequent decades. Today, only 2 B-29 seconds remain airworthy, preserved and maintained by dedicated organizations, ensuring future generations can witness these historic aircraft. When these bombers fly at air shows, there are 3,350 engines producing that distinctive deep-throated sound. Few spectators realize the technological revolution these aircraft represented. The pressurization systems still function, maintaining cabin pressure differential as aircraft climb through altitudes where crews in earlier bombers would have required bulky oxygen equipment and heavy protective gear. The story of Pacific Pioneer returning to Saipan with 52 flak holes and 3 feet of stabilizer missing represents not an isolated incident, but a pattern repeated across hundreds of missions. B-29 seconds returned from raids with 1 or 2 engines shut down, hydraulic systems partially failed, pressurization compromised, and structural damage that would have destroyed lesser aircraft. The bomber's ability to sustain such damage and continue functioning testified to engineering excellence, industrial quality, and manufacturing precision that Japan acknowledged it could not match. First Lieutenant Toshio Ota, a technical intelligence officer who survived the war, later wrote that examining captured American aviation technology induced despair among Japanese engineers. Every system, every component demonstrated manufacturing sophistication beyond Japanese capabilities. Pressurization systems particularly impressed him because their operation involved complex interactions of compressors, heat exchangers, pressure regulators, and structural seals, each requiring precision that Japan's war-damaged industry could no longer achieve. Even had Japan somehow obtained complete pressurization system designs in 1941, he concluded, the nation lacked industrial infrastructure to produce them in meaningful quantities. The altitude immunity that pressurization technology provided to B-29 crews fundamentally transformed strategic warfare. Before the Superfortress, high-altitude bombing remained theoretical concept constrained by human physiology. Crews could operate unpressurized aircraft at 25,000 feet for limited periods with oxygen equipment, but extended missions produced debilitating fatigue, cold injuries, and degraded performance. The B-29's pressurized environment allowed crews to function effectively during 10 to 12-hour missions, maintaining alertness and coordination necessary for precision bombing and defensive operations. This capability created operational sanctuary that Japanese defenses could not penetrate. When American bombers cruised at 30,000 feet over Japan, their pressurization systems functioning smoothly within design parameters, they carried more than bombs. They carried proof that industrial might had become the decisive factor in modern warfare, and that America possessed that might in quantities no enemy could match. Japan never expected this reality, and once the silver bombers filled the skies over the home islands, operating beyond defensive reach, there was nothing Japan could do to stop them. The technological gap that pressurization represented was not absolute. Germany had developed pressurized aircraft. Britain pursued similar technology through different approaches. But only America made pressurization standard equipment on heavy bombers, accepting additional complexity, cost, and maintenance burden in return for unprecedented operational capability. This decision reflected industrial confidence. Pressurization systems required precision manufacturing, regular maintenance by skilled mechanics, and steady supply of spare parts. America possessed the infrastructure to support these requirements. Japan did not. The final accounting of the Pacific Air War validated strategic principles that would govern military aviation for decades. Technological superiority could overcome numerical inferiority. Industrial capacity mattered as much as individual courage. Air power alone could destroy a nation's ability to wage war. And altitude, that vertical dimension of warfare that previous generations had barely explored, became a sanctuary where engineering excellence purchased immunity from conventional defenses. The B-29's pressurization systems, spinning compressors, forcing thin stratospheric air into sealed compartments at sea-level equivalent pressure, represented the foundation of victory as surely as any weapon system deployed during World War II. When the war ended on August 15, 1945, with Japan's surrender announcement, "The sky's over," Tokyo fell silent for the first time in 9 months. No silver contrails marked bomber formations at 30,000 feet. No anti-aircraft shells burst uselessly in thin air thousands of feet below their intended targets. The technological demonstration was complete. The lesson was learned. And the age of high-altitude strategic bombing that the B-29 inaugurated would continue through jet bombers, intercontinental ballistic missiles, and eventually into the space age itself, all descended from those pressurization systems that allowed American crews to breathe normally while flying through air so thin that Japanese defenders could not follow. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.